Hello, welcome to Robert Wilson's Pong tutorial. I'm basically going to run you through the importance of using geometry in a Pong game pretty much, and here we go. So let's go ahead and select the Pong barrier game, and we're going to use Microsoft Visual XNA Studio, the Express Edition, which anybody can download online, which is very nice. Let's go ahead and just start through with what the game holds. Over on the right you can see that we have our ball image and our paddle image, and we'll be loading that in our content manager content pipeline a little bit later. We also have a couple classes here. You got your ball class, your game class that we're looking at the moment, and a paddle class. Let's go ahead and start with the paddle class real quick. In the paddle class, it's pretty basic. We describe the point of the paddle, the new point of the paddle, and its speed. So fairly simple. In the ball class, you can see that we go ahead and take an XY coordinate of the ball, we make a new point for the ball, and we give it a random velocity. And this velocity and speed, you'll see in the game section why we have to use that, but basically just changing the speed of the ball. Up here we're going to describe a bunch of different vectors that we're using in the program. And they range anywhere from some of the text vectors, the font vectors, and the player scores. Down here we're going to make 3 instances of paddles because we're actually using 3 paddles in our Pong game, and you'll see that later. And we already showed the paddle class, so you know what these paddles pretty much are and mean. So let's go ahead and move on down. You'll also see the ball class there. We'll start with the update paddle section. In the updates paddle section, you will see that we're going to trap the user's input to determine which direction the paddle is going to actually go, either up or down. Down here, we're going to actually produce a little bit of AI. Basically, all we're going to do is follow the ball with the computer's paddle, and also the barrier paddle, which is in the middle. So as the ball is going up, our paddle will be going up, and vice versa. This gives us a little bit of AI in there real quick. Obviously it's not very hard to beat this computer game, so a better AI would probably have to be drawn, but it works for this tutorial. In our update ball section, all we're going to do is update the position of the ball and then check its boundaries, if it's crossed the window or if it hasn't, and we're going to change its velocity and its speed. Basically, every time the ball hits the paddle, it's going to actually have to change velocity and speed and direction. Every time it misses the paddle, it's going to reset the game. So every time it hits a boundary. In the reset game section, all we're going to do is start the paddles back at the middle, start the ball at a certain spot. We start the ball, start our barrier at the same spot, and the game will reset. Now the check collision section is a little bit longer, so we'll go ahead and save that till a little bit later. In our initialize section, there's really not much to do there. We're not initializing too much. Our game section, all we're doing is setting up the graphics device manager and pretty much doing nothing else there. Load content section. All we're going to be doing in our load content section is load our 3 different paddles, then we're going to load our ball, and I would load a blank window for a screen section later on, but you don't have to worry about that part. And in our unload content section, there's really nothing we're going to unload in there. We don't really need to. XNA takes care of most of it anyway. Our update section. This right here will allow the Xbox 360 controller to be used, but we actually just ended up making it a Windows PC game, but it's very quick and easy to change it over to Xbox. Under our current state section, all we're going to do is check to see if the statistics button, which is S, or D has been pressed. Once again, this is just something I added real quick in the Pong game, which doesn't really need to be in there. In the game stats here, we're going to check to see if the game stats is false. So basically all we're going to do is update the ball, update the paddles, and check for our collisions. That's what we're going to do every time that the ball either goes through the paddles or hits the paddles, or pretty much every time anything happens in this game. So we'll skip down to our draw section. we're going to basically draw the background, which is cornflower blue, and we're going ahead and draw paddle 1, then draw paddle 2, and then draw the barrier. Of course, we got to draw the ball, and this is kind of I've inputted some scoring and some statistics and stuff and frame rate, which you can very easily. And all we're going to do down here is also it's the same thing. I put some statistics, some scoring, some who's losing, who's winning, stuff like that. So that's really all we have in the draw section. So let's go ahead and go up to the check collision section, which is a little bit longer. And there it is. Alright, in games, if you don't know your geometry, you're kind of in trouble, because how do we know when the ball is going to hit the paddle? We have to know the collision of that, and to know the collision of that, we have to know how to determine a rectangle. And basically, we're going to take the height of the rectangle. If it's less than the paddle position 1, then it went through. So you basically ended up losing. So if you don't know how to determine x and y coordinates on a rectangle, or your circumference of your ball, the game won't run right, and you won't know which direction to change the ball as it moves to the left or as it moves to the right. So let's take a quick look at this. Basically, all we're going to do is see if the ball's moving left. We want to know if it's moving towards paddle 1. If it is, we're going to see if it's actually surpassed paddle 1. If the ball has hit the paddle or it went through, is what we're doing right here. So basically, if the ball went through the paddle, we lose. We can see that right here. Reset the game and give the computer a score. If it didn't, then obviously it hit the paddle. And if it hit the paddle, we got to know how to change its current speed, and we have to know how to change the direction of the ball. And the direction of the ball, is still geometry, because we have to invert the ball, and we have to invert the ball the right direction. So we'll see right here that we're going to check the speed of the ball, and then we're going to give it a random integer for its speed and a random direction. And that's pretty much it. Down here we check the right paddle, and down here we check the barrier. So that's all we're pretty much doing in the check collision section. We're checking that the x coordinate, the y coordinate of the paddle 1, which is our user paddle, did not surpass or did surpass the actual ball. Then you lose. Otherwise, make it go the other way. Sounds pretty simple, and it is, but you kind of have to write it out to get the logistics of it. So let's go ahead and give you guys a quick demo of the program, and hopefully it'll start fairly quickly. Alright, and there it goes. And this is my long tutorial, but as you can see, I'm losing right now, so that's not good. But as you can see, the barrier is following the ball's position, as is the computer's paddle. And I did not score still, and so I'm still losing. But as you can see, if the ball hits the barrier, you're losing. So anyways, that's pretty much what we have here, and I appreciate your time. Again, my name's Robert Wilson, and if you have any questions, you can always post on my blog, and I should be able to get back to you. You guys have a good day. And there you go. You can see my guy moving up and down on the left-hand side. You can see the computer barrier in the middle moving by itself, and the barrier on the right side also moving by itself. And you can also see me not doing so well. I'm losing right now pretty badly, but again, my name's Robert Wilson. You guys have a good day.